Alright, so this demo is about how your company can become your own secure boot UEFI certificate authority, how to implement a semi-simplified signing infrastructure, so the company you have won't have to waste time on bureaucracy or waiting until someone else decides that they can finally sign your shim and your firmware and your bootloaders. So a bit introduction. I'm Kamil, someone who is interested in reasonable security. That means something that is secure and doesn't get in the way. So I can work freely without worrying about the tooling being uncomfortable, so it damages the actual work. I also do some volunteer contributions in the shim review process and help companies make sure that their binaries are alright when it comes to their characteristics and are safely maintained. And I'm also one of those freaks that like paperwork, so you all don't have to do it yourself. And this will be important in the context of the shim processes. So let's say that your company requires, for some reason, a UEFI Secure Boot, a certification, maybe because your customers demand it or there's something else going on. So the information your company has is first that it's a lengthy process that you sign up here, you sign up there, then Microsoft does this whole certification. And then you set up your infrastructure so your employees can build an actual shim, a bootloader, and a kernel, set it up to have a working system, and conform to the requirements of the shim review processes, which I also maintain and try to simplify so it also doesn't get in the way. So after you file an application, unpaid volunteers like myself do the whole paperwork in my spare time, review the application, and if it's good, yes, the first stage is completed. So then let's go to the second stage. You sign up for Microsoft Hardware Dev Center file signing services, upload your EV signing certificate, upload a signed cabinet file with your shim binary inside it, the one that I helped review, and then you receive the same shim back, and your engineers can implement a whole boot chain that works with Microsoft keys. That's the theory. So how it works in practice. It looks kind of sad. First things foremost, when you try to sign up, there might be some issues with signing up, and you might need to open up support tickets and wait a few months until it's all operational again, or because the domain called onmicrosoft.com is claimed to not be a valid Microsoft domain, despite the whole venue assigning you this exact domain as a contact email address. Yes, that's kind of sad, but that's the reality. Or you have to buy another signing certificate because it's supposed to be invalid, or you wait a few minutes until the server replies back. That's assuming that your signed cabinet file is alright. Or once you have your application, there's absolutely no activity, so it's better to just close it and open another one. So can we do any better? Yes, we can. The point of this presentation is that you should be in control of your equipment, your firmware, your keys, and your signing processes. But this means the responsibility to maintain this infrastructure. For instance, which of your employees can access certain parts of the infrastructure, several nodes, several, let's say, bunkers in your company, or safes, or any other physical measures that can protect the company from rogue employees or some other malicious actors. Also, how do you handle revocations? How do you handle incident responses, firmware updates? How do you back up your nodes, HSMs, or anything else? This will be mandatory, although this demo doesn't cover them because it's a simplification. Just get the idea of what I'm about to convey. This slide is a bit controversial when I say that HSMs on Linux usually are a pain to work with, despite the fact that HSM vendors do a great job. at building the hardware and maintaining them and supporting them. The very moment you're trying to use the PE sign utility, either in standalone mode or in client-server mode, you are going to run into some problems sooner or later. So this then will account for some weird shenanigans. For instance, the new fact that sometimes you will have to have your HSM pin in memory or do some other weird insecure workarounds so that the whole infrastructure, the holistic approach will be reasonably secure. So for instance, the node, let's say a laptop that your engineers use to build the actual boot chain cannot know the actual pin and cannot steal the keys. So this is how the infrastructure might look in a simplified form. The rectangles are like physical compartments in your company. So when you have a security certification and a policy which employee can access which parts of, let's say, the company building where the physical nodes are located, this prototype says how to divide it. And you can see some of the nodes will be used only with the utmost high security clearance, and their names are referencing more or less to how I name my cubes domains. Also, the new fact that this lab prototype will heavily rely on the cubes nomenclature, the vocabulary, and also reference cubes air. Once it's realized, this is really going to simplify the whole approach in practice. So you can see a node called assets generator on the left bottom side. So let's enlarge it and how it's going to work in practice. This node can be used to generate all the private keys and the public keys. And also the arrows show how and where they can be transferred further. So for instance, all the public stuff like the FE signature lists, this means the .out files and the certificates, they can be uploaded to the internet. No worries about them. Some of the most important stuff like the private keys will go to the top secret vault, which should never leave the high security clearance area in your company. There will be also two other nodes. Let's start with the PKCS back transfer one. So when you generate a PKCS back, which will hold your public and private key, this will be transferred to an HSM. And I will cover in the next slides of why the HSM isn't directly connected to the assets generator. So let's see how this will work. Oh, by the way, some of the nodes will be shredded, just like the Cube's disposable VMs for utmost security. So especially the most neuralgic private parts can no longer be recovered. So in this case, you just transfer the PKCS back to an HSM. Also make sure you have a backup HSM just in case. Also shred that node. Then the shim signer node will hold the DB key, private and public key, and will act as some sort of an application that whenever your engineering team handles you an unsigned shim they build, this will provide a signed equivalent. This doesn't, of course, mean putting the unsigned binary directly in its file system or anything else for that matter. It's, like I said, a simplification of what's there to come. How you realized it? It might be some sort of an RPC service or anything else that can be realized in practice and be compliant with your company security policy. And here's the not so fun part. Like I was saying earlier, some weird insecure workarounds are very likely to happen because of the PE sign utility not being that great. So for instance, let's say that your case is so specific that you need to hold the pin in memory, which is completely insecure, and how to realize building the bootloader chain so as to provide the reasonable security I was also talking about. Well, the bootloader builder node, which can mean, for instance, a laptop that your engineers use to build your bootloader, your kernel, and then compile a whole operating system. This node will never be able to know the actual pin. So for instance, it might communicate with the bootloader signer node that knows the pin with some sort of secure RPC framework channel. For instance, qrexec and the cubes.p sign application, or maybe something else. So this concludes the simplified prototype. There are a lot of cases which were not covered here, and in practice will be tailored to your company policy requirements if you find this demo quite reasonable. So, any questions?